Assalamualaikum dear students. This is Sir Muneeb's name again with the new video on the new paper of October-November series 2024 paper 1 variant 1. So I will be continuing with this series with the paper solving. So if you have any queries you can let me know in the comment section or reach me out on my WhatsApp number. For this paper I just checked out that there are almost 13 questions which are repeated from the past papers. So first of all, I will go through those questions which are basically taken from the past years. Question number 5, 6, question number 8, and question number 8 is taken from two different years. Question number 12, 13. In fact, question number 13 is taken from May-June 2003. It is very old paper. After that comes question number 21, and it is in fact a part of the examiner report. Currently, examiner report is not yet updated on the website, so it will become out later on. Question number 25, question 27, question 29, 30, 31, and this is also taken from very old year 2024, 2004. Question 35, 36, and that's all. So these are many questions which are repeated from the previous years. Okay, now let's start. The first question in this question Q is used to represent a halogen atom. Magnesium, calcium each form a compound with chlorine and compound with bromine. One of these compounds contains this. So we have to identify which element is present out of these two elements, the magnesium and calcium, in the compound Q. So magnesium and calcium, one of these two is present, and from the second point, the element from the group 17 can be either chlorine or bromine in the compound Q. We are given these properties. Accordingly here, it says that the element group 2 with a higher first ionization energy. So we have to find from magnesium versus calcium. If you see in the periodic table, the magnesium is present higher in position as compared to calcium. Calcium is just below the magnesium. Now it says higher first ionization energy, and we know according to the trend that the high ionization energy, or you can say down the group, ionization energy decreases. Down the group, ionization energy decreases, which means magnesium must have the higher ionization energy than calcium. So that's how we can find that magnesium is a right compound, is the right element in the compound Q. The second point says that group 17 must have the higher Q bond energy. Q is basically the atom, so it is a halogen atom, which means it indicates the bond energy between two atoms of the element Q. Okay, down the group, if we move down the group in group 17, group of 17, the distance increases, the size increases, and that's why the covalent bond energy, the bond energy decreases. Size increase, it is the inverse relation. The size, when size increases, then the overlapping of the atoms becomes less, and that's why bond energy becomes less. So we have to compare between chlorine and bromine. Chlorine is present higher in position than bromine. So down the group, bond energy decreases, which means chlorine must have the higher bond energy as compared to the bromine, because chlorine is smaller in size than the bromine. So chlorine is the right answer from these points. Chlorine has a higher bond energy. So on this basis, we can see that double ticks are coming on compound first compound. So A is the right answer. Then second question, compound X contains two elements Y and Z, and their information is given here. They are saying the element Y is such type of the element in which the p subshell has all the three orbitals occupied. All the three elements, all the three orbitals. P subshell, as we know, contains three p orbitals: px, py, and pz, and it says that all three are occupied, which means they can contain either one, or they can in fact contain two electrons in all of them, either one each or two each or any random combination. But it has clarified that only one of these three is fully occupied. Only one of these three, which means this element Y must have Px, Py, and Pz, out of which only one orbital is completely or fully occupied, whereas the other two orbitals are not fully occupied. And say it is present period 2, which means this p subshell must be present in the second shell. So I will put 2 in front of here. As we also know that the p subshell comes later after the s subshell. S subshell comes before p, which means the electronic configuration should be like this: 2s2, 2p, 4, since there are 4 electrons in total in p subshell. That's the electronic configuration of this. Now from here we can conclude that this element must be present in group number 6, since there are 4 electrons in the last shell, 2 electrons from S and 4 from P, which means if we look for the combinations or the options given, the element of the group number 6 is oxygen. So it is oxygen here. I'm just writing OX just to make it clear, it is oxygen. So it is Y element is the oxygen. Then the element Z. Now for element Z, it says that in one atom Z, the p subshell has only two orbitals occupied. Has only two orbitals occupied, which means it would have px and py occupied with one electron each. They're just one electron, and pz is totally empty. And this belongs to group number period number 3, which means these p subshells are from quantum number 3, and definitely it is followed by the s subshell, which means the electronic configuration should become 3s2, 3p2. Now this is the last shell, and the group number is clearly seen. It is group number 4. So 4 is a group number. So element of period 3 and group number 4 can only be silicon. Silicon is here and silicon is here. So the double ticks comes on the compound of C option. So C option is a right answer. Now question number 3. This salt consists of crystals of hydrated sodium sulfate, which can be used for the manufacture of detergents. When a sample of this salt was heated, 1.91 gram of water was removed, leaving 1.5 gram of this as anhydrous. What is the value of X in this compound? So basically, it belongs to the this question belongs to the chapter of moles. Now, how do we attempt this question? First of all, we must find the number of moles of both the water as well as the moles of the anhydrous sodium sulfate, which means we must have the masses of water as well as the mass of the anhydrous compound, which is already given. So I will first calculate the moles of the water. So moles of the water will be mass divided by molar mass. So the mass of water removed is 1.91 gram. So 1.91 divided by the molar mass of the H2O, which is 18. The answer is 0.1061 moles. I have to calculate the moles of anhydrous sulfate as well. Moles of Na2SO4. It is equivalent to its mass. Now, mass of anhydrous is given 1.51 gram. So 1.51 gram of anhydrous, and its molecular mass must be calculated separately. You have to use periodic table to calculate its molar mass, its MR value. It must be 23 times 2 plus 32.1 plus 16 times 4. Answer is 142.1. So 142.1. The answer is 0.01063 moles. After that, we have to take the ratio between the moles of water and the moles of the sodium anhydrous sulfate. So smaller, as we can clearly see that moles of the sodium sulfate is smaller. So 0.01063 divided by moles of the water, 0.1061. The answer is nearly equal to 9.98, which is converted into the digit as 10. So 10 is the right answer here. Question number 4. What contains the greatest number of named particles? So we are given some information here and we have to conclude which contains greater number. So here 6 dm cube argon means it must be converted into its moles. Then from this value we will convert into the moles, and from moles we'll multiply with the Avogadro's number, which is 6.02 into 10 to the power 23. That is the Avogadro's number. So I have to do this separately for every species given. 6 dm cube divided by 24 dm cube, like it is volume divided by molar volume at room condition, because condition is given, so it must be 24 dm cube. The moles come out to be 0.25. Now this 0.25 multiplied with the Avogadro's number. I'm not writing the answer because we are all concerned with the moles here, because for 1 mole the number of particles is one Avogadro's number. So now next, 6 gram of carbon dioxide molecules. First we have to convert into the moles, which for this purpose I need molar mass. Carbon dioxide is 12 plus 32 is equal to 44. So moles will become 6 divided by 44. The answer is 0.1364 moles. You can easily compare this value with the previous one, 0.25, since it has to be multiplied with the Na later on. Then about the magnesium, the relative atomic mass of magnesium is 24.3. So moles will be 6 divided by 24.3. Magnesium we write just one atom. Answer is 0.2469 moles. So I am underlining all the moles here. We will get our answer from these underlined answers. And for water, MR is 18. So 6 divided by 18 gives me 0.33. Now I have calculated all the moles here, and we are supposed to find with the greatest number of particles, which means the one which has the greatest number of moles will be the right answer. So here The option A and C are almost same, 0.25 each, but D has the highest value. D has the highest number of the moles here, which will be multiplied with Avogadro's number. Sorry, with the Avogadro's constant. So that's why D is the right answer. This question is repeated from the past paper. You can also watch the video on this question by any other student or teacher. This question says phosphorus form a compound with hydrogen called phosphine, pH 3. This compound can react with the hydrogen ion. Which type of interaction occurs between pH 3 and hydrogen ion? Okay, we know that pH 3 is similar to the NH3 since nitrogen and phosphorus both are in group number 3. They are similar. And nitrogen has a lone pair, which means phosphorus will also have a lone pair on it. And hydrogen ion is completely empty. It has no electron present in its shell, in its own shell. So this ammonia will share its lone pair with the hydrogen ion. So this type of the bonding we know is called the dative bond. This is called a dative bond in which nitrogen will make dative bond with the hydrogen. But we are discussing about the phosphorus, so it will be the same. Instead of writing 9 nitrogen, I can write P, and over here P. pH 3 bonding with the hydrogen ion. So this type of the bond is called the dative bond. Question number 6. It is also a repeated question from the previous year. The graph shows the trends in 4 physical properties of element excluding argon. Which graph has electronegativity on the y-axis? So you must remember or recall that the electronegative value across the period, we have to indicate across the period what shall be the trend. So across the period, electronegativity value increases. There is an increasing trend. Electronegativity value increases in the period. So we have to find that graph here. This is can be seen in C and D both, but C has also decreasing. It is not actually increasing, it is also decreasing at some points. So D is a only option here with an increasing electronegative value across a period. Next question number 7. The element exists in two forms, creatine and whitine. We have the values given here. Which structure change might take place when creatine changes to whitine? So, creatine to whitine means we first identify what kind of structure has creatine and what kind of structure does whitine contain. From the electrical conductivity, these two values, the boiling point values are too high, which means both are giant compounds. But the thing which can differentiate them is the electrical conductivity. The gratin is basically a kind of a covalent since it cannot conduct electricity in solid or liquid. On the other hand, a substance which can, since we are given options, covalent on the left side, so I have to differentiate between covalent and ionic. So it can only be covalent, and on the basis of the uh, malleability, this compound gradient can be, since it is written brittle. So we know that ionic compounds are brittle and the covalent are also brittle. Both are brittle. So it means that both these properties indicate that it is basically a covalent, not an ionic. Since uh, covalent is present in both these two rows, the property matches with the covalent nature. So gratin is basically covalent. Now about the whiten. In front of the electrical conductivity, we can identify that if it is a good conductor in solid form, then we know that the metal is basically a good conductor in solid form, since we have to check from ionic and from metallic as well as covalent too. There are three possible possibilities here. And the electrical conductivity in liquid, which means it can be metal in the molten form, or it can be ionic in its molten form. Any of these combination can exist. And malleable. The malleable property belongs only to metal. So both metal property is present in both these properties, malleability and electrical conductivity. So which means this white tin is a metal. It is a metal, and this one is a covalent. So metal from here. So the option with two ticks is the B option. That's the right answer. Question number 8. Which solid has a simple molecular lattice? And this question is repeated two times previously. Simple molecular lattice. The calcium fluoride is an ionic. Nickel is a metal, but it is not simple. Silicon dioxide is a giant covalent, and the sulfur is a simple molecule whose formula is S8. It contains 8 atoms of sulfur. So that's the right answer, D. Question number 9. The standard enthalpy change uh, of combustion of carbon or hydrogen butane is given, and we are supposed to find the standard enthalpy change of combustion of butane. Okay, this is a formation value, which means we need to have a good picture of the Hess cycle. I have to draw Hess cycle here, only then it will be possible to find the answer. So we know that carbon and hydrogen both will show combustion in the presence of the oxygen. So in the presence of the oxygen, it will convert into the carbon dioxide, and hydrogen will convert into the water, and the carbon and hydrogen combine will both combine to produce butane. The butane's formula is C4H10, and this combustion of butane is also given, but not the value. It says it will combust in the presence of the oxygen to form carbon dioxide and water. And we have to find the enthalpy change of butane. X is here. The X is unknown here. The value for the formation of butane is given, which is minus 129. Now we have to balance this equation as well. According to the number of carbon atoms and hydrogen atoms, there are 10 hydrogen atoms, so I have to balance hydrogens. I shall multiply it with 5, and 5 must be also written here. And carbons, there are 4 carbons, so 4 carbons and 4 carbons. Always balance the carbon atoms first. Okay, now they are balanced. The value for the enthalpy of combustion is given, which is minus 394. Minus 394 is given for 1 mole. So for 4 moles, I have to multiply this value with 4. 4 multiplied with minus 394. So it will be minus 1576. And for hydrogen, value for 1 mole of hydrogen combustion is given minus 286. But it shall be multiplied with 5. So 5 times this will give minus 1430. Okay, now we have to calculate the value of x. Over here, according to the vector addition rule, we have to add arrows. Over here, arrows like this must be added into each other. I'm making it simple here. I will label A, B, C, D here. This is A, this is B, and this is D. A and B will combine to give resultant vector D. A, B will be added to each other to make D. So apply the same formula here, which means minus 1576 and minus 1430 are added. Minus 1576 plus minus 1430 are added, and these are added in this vector minus 129 plus minus 129, and it shall be equal to the resultant vector. X is the resultant vector x here. So if you do the calculate, you will get the answer. X will become minus 2877. So minus 2877 is the right answer. Now question number 10. Question number 10 says three processes are described. We have these processes here. The first process indicates hydrogen reacts with hydroxide to make water, second and third. Which statement is correct? We have to find the positive and negative signs. The first reaction is indicating that it is basically the uh, ionic equation of the neutralization. So neutralization reactions are always negative. They are always exothermic. It is ionic equation of the neutralization. Second case indicates the combustion of the methane, and combustion reactions of organic fuels are always negative. And the third indicates the change in the physical state from gas to liquid. It is basically the condensation process. The condensation process is the one in which highly energetic molecules uh, convert into the less energetic. So there is a loss of heat. The loss of heat or energy, which means it is also a negative. So all these processes are negative. So the only right option in this case will become A, in which none of them has a positive enthalpy. Next question, number 11. In alkaline condition, MnO4 ions oxidize the sulfite ions to sulfate ions. The MnO4 negative ions are reduced to MnO2. What is the ratio of the two ions in the balanced chemical equation for this reaction? So we have to construct the equation to find out the answer. Over here we have MnO4 which is negative ion. It reacts with the sulfite ion which is SO3 minus 2, and it converts into the SO4 2 minus plus Mn. According to here, the product is MnO2. Now, this reaction is occurring in the alkaline solution, which means the hydroxide ions must be present in this equation, which I currently don't know where, either on the left side or the right side, but that will be decided later. Right now we have to find the change in the oxidation number, which will help us to indicate which will be oxidized and which will be reduced. So I have to write the oxidation numbers here. That will help me. The oxidation number of manganese in the MnO4 is plus 7. On the right side it is plus 4. Now about the sulfur. On the left side, the sulfur has the oxygen state of, if you check, 3 times 2 minus 6, so it will be plus 4. Sulfur is plus 4 here, and on the right side sulfur is plus 6. I have calculated the oxidation numbers. Now what shall be the change? We have to check the change in them. Manganese is changing from plus 7 to plus 4, which means the oxidation number change is -3, it is reducing, and for sulfur it is +4 to +6, the change is +2. It means there are 3 electrons lost, there are 3 electrons gained by the manganese being reduced. So I can write it like this: 3 electrons plus 3 electrons. I will just write 3 electrons are gained in case of manganese, and in terms of the sulfur, there are 2 electrons. There are 2 electrons which are lost, -2 electrons. Now the electron must be equally. We know the rule of the redox relation, that electron lost must be electron gained. Electron lost must be electron gained. So I have to balance them. For balancing, I have to write multipliers here. So 3 must be multiplied with the number to make it equal to the electrons which are lost, and that should also be multiplied with that number. So 3 times 2 and 2 times 3. These are the numbers which will equal them. Both will become 6 electrons each. Now the numbers which I have written here must also be written with the species on the sides. So I will write this 2 must be written with 2 here, and this 2 must be written over here, and this 3, it must be written over here, and 3 over here. Now I have balanced the atoms of sulfur and manganese according to the oxidation number, but still it is not completely balanced. I have to indicate the charges as well. The charges we check, the charges on the left side would not be equal, as well as the oxygen atoms. You can check them by yourself. The oxygen atoms will not be equal, and the charges will also be not equal. If I go for the charge, if I go for oxygen, I can see that there will be uh, oxygen. If I check the oxygen atom, 4 times 2 8, 3 plus 3 6, 9. Sorry, 3 times 3 9. So there are 17 oxygen atoms over here, and on the right side, 4 3 12 plus 2 to 4. There are 16 oxygen atoms. So it is not balanced, which means something is missing, and that is the OH negative. Same reaction is occurring in the OH. But where should I put oxygen? That depends on the charges. If I check the charges, then now we can also check the charges. Here, the 2 is multiplied with -1 charge, so it is -2 on the left side, on this side, and 3 will be multiplied with this -2 charge, so 3 times 2 -6. So in total it is -8 on the left side. Now we calculate the charge on the right side as well. So 3 times 2 will give me -6 over here, and 2 times, no, there is no charge on the Mn. So in this case it is 0. So total negative charge on the right side is -6. So -8 on the left and -6 on the 6 on the right. So we see that the charges are also not balanced. Just like oxygen atoms are not balanced, in the same way the charges are not balanced, which means we have to take into account this hydroxide ions. Now where to put this hydroxide ion? We can see clearly here that since the negative charge is less on the right side, so I would put the hydroxide ions on the right side, and I will multiply this hydroxide ion with 2, so that the charges are balanced. So 2 times of this minus will give me -2. So -2 added into -6 will give me -8. So there is total -8 charge. It is now equal to the negative charge on the left side. Now about the oxygen atoms, as we checked before, that there were previously 17 oxygen atoms on the left side, and there were 16. Now I have to add 2 more oxygen atoms in it. So 2, 16 plus 2, will give me 18 oxygen atoms on the right side. Now, there is a problem. We have also introduced the hydrogen. So to make the hydrogen equal, we have to add water on the left side. For this purpose, we will take two molecules of the water on the one molecule of the water on the left side, so that hydrogens are balanced. Now oxygen is also introduced on the left side, so oxygen must be added here. So 1 plus 8, so additional 1 oxygen is added. Now this will give me 18 oxygen atom on the left side, 18 oxygen on the left side, and there was already 18 on the right side. Now in this form we have balanced this ionic equation. Now we can now simply say we can now simply find out the ratio of the two ions. The ratio of the two ions in the balance equation, it was to be taken ratio between MnO4 negative and SO3 negative. So there is 2 on the MnO4 and there is 3 on the SO3. So the right options from the table, we can see 2 from this column and 3 from this column. So that's how the right answer is option A. Now question number 12. Lithium reacts with nitrogen at room temperature to form solid Li3N. Three vessels if equal volume are connected by taps 1 and 2. So we have this scenario in which there is an equilibrium reaction inside in the central vessel, and there is a lithium metal on the right, on the right vessel, and just vacuum on the left vessel. They are asking in which case we would get the maximum amount of the ammonia, which means more ammonia is produced. So we can expect here that if we open the valve 2, then the gas of ammonia, the nitrogen gas, will move to the right and it will react with the lithium to make the lithium nitride, and this will reduce the amount of the nitrogen, which means the equilibrium will shift to the backward. So we can see clearly that valve 2 must not be opened. It should not be open. Now about the valve 1, if we open it, if the valve 1 is open, then this will lead to an increased volume. The volume of the vessel 1 and volume of the vessel 2, they are both open, which means there shall be an increase in the volume. The volume of the system will increase. We know a relation that volume is inversely proportional to the pressure. If we increase the volume by opening the tap of 1, if we open tap 1, the volume will increase. It means the pressure will decrease. The pressure on this system will decrease, and according to this equation, there are 2 moles on the right and there are 4 moles on the left. So there is less pressure on the right. We know that there is less pressure on the right. If we increase the volume by opening the tap 1, then pressure will be reduced. So to compensate that, and according to Le-Chatelier's principle, the pressure must be increased. We have to increase the pressure, and the pressure is increased on the left side. So to increase the pressure, it would move to the left side. That will reduce the amount of the ammonia yield. So ammonia will be decreased. So opening the valve 1 will increase the volume, that will reduce the pressure, and so to oppose that change, the equilibrium will shift to the left side to increase the pressure, and this will reduce ammonia. So that's why tab 1 should also not be opened. In that case, we can see that both tab 1 and 2 must be closed. So that's why the right answer will become A. Our next question, number 13. When 0.2 mole of hydrogen gas and 0.15 mole of iodine gas are heated to 723 Kelvin until equilibrium is established. We have this equation. Now in this equation we are given some data which we have to use to find the answer. We are given that the 0.2 mole of hydrogen gas and 0.15 mole of hydrogen gas was used to heat, and at the equilibrium point we had 0.26 mole of the hydrogen iodide. 0.26 mole of the hydrogen iodide was present at equilibrium. This is the volume, this is the moles of the hydrogen iodide at the equilibrium, and 0.2 mole of hydrogen gas, 0.15 mole of iodine gas. Okay, we can apply the uh, we can use these values initially. If I'm writing initial I and I here, and equilibrium on this side. This is the equilibrium stage and this is initial stage. Initially there was 0.2 moles of the hydrogen gas and there was 0.15 mole of the iodine gas, and at this initial stage there was no mole of the hydrogen iodide. But when equilibrium was achieved, then at equilibrium there was 0.26 mole of the hydrogen iodide, and we do not know how much moles of iodine was present, X, and how much mole of hydrogen was present there. So to find the equilibrium amount of the hydrogen and iodine, we need to do some calculation. Over here, we can see that when equilibrium was achieved, there was, in according to this equilibrium reaction, there is 2 moles of the hydrogen iodide and 1 mole of hydrogen and 1 mole of I2. So it indicates that 2 times more amount of the hydrogen iodide is produced while moving from 0 to 0.26, and half moles of the iodine will be decreased, and half moles of the or H2 will be decreased. That's what we have to find here. So 0.26 moles was produced when there were 2 moles. For 2 moles, so for 1 mole it shall become 0.26 divided by 2, and the answer is 0.13. So 0.13 moles of Hi is produced when there is just 1 mole of it. Now this 0.13 is the amount to be subtracted from the amount of the hydrogen and iodine from the initial values. So for H2 I will write H2 amount at equilibrium. H2 at equilibrium will be equal to its initial value, which is 0.2 moles, minus the mole at equilibrium, that is 0.13. So the answer will be 0.07. And for the iodine at equilibrium, its initial value is 0.15 minus 0.13, it gives me 0.02. Now this is the equilibrium amounts of the hydrogen and iodine. Now we have to use the expression Kc is equal to Hi with the power 2 because it has coefficient 2, and H2 times I2. We have to substitute their values. So the 2 moles, we have to substitute the values here. So hydrogen iodide is present by 0.26 at equilibrium, so it is 0.26 in the numerator with square, and in the denominator we have to check the values of the hydrogen and the iodine. The correct values for the hydrogen is, we know, is 0.07, which is given here and nowhere else, and the value for iodine is 0.02, that is also given here. So that's how the correct answer becomes option C. Now our next question: in acidic condition, this is a reaction which is occurring. The kinetics of this reaction, the kinetics of the reaction are investigated using colorimeter. Colorimeter is a device which indicates a color, which shows a color, or which can measure the color change. It is a device which measures the color change. And as iodine reacts, the yellow-brown color of the iodine fades to colorless, changing the absorbance of the solution. Non-concentration iodine are used to prepare calibration curve graph, and the absorbance is then measured as reaction proceeds. So in this case, we are looking at the color of the iodine, which is fading with the passage of time as the reaction is proceeding. We have to find what is the rate of the reaction at 20 seconds. At 20 seconds. So basically, we have to look at both graphs. We have to use both graphs. If I look at the right graph, which indicates that the time is mentioned from 0 to 20 seconds, and at this point, the value of absorbance is given on the y-axis. So at 0.5 to 20 seconds lies on the 0.3 absorbance. 0.3 absorbance comes right in above the 20 seconds. So the change is from 0.5 absorbance to 0.3 absorbance. Now we have to look the same absorbance change on the left graph. On the left graph, the 0.3 absorbance is present here and 0.5 absorbance present here. On this graph, we can find the change in the concentration during this reaction. So the change from 0.5 to 0.3. At 0.5, the value is 0.25 into 10 raised to the power minus 3. So 0.25 into 10 raised to the power minus 3, and the value of 0. In front of 0.3 is 0.15. So that's the decreased amount or the used amount of the iodine. Since the direction is moving in the forward direction, which means iodine amount will keep decreasing. So how much is amount used? That is calculated here. 0.25 minus the value in front of the 0.3 is 0.15. So 0.15 into 10 raised to the power minus 3. Now if I take the difference, it is 0.1 into 10 raised to the power minus 3 mole per dm cube. And that's the change in the concentration. The rate of the reaction is basically represented as change in the concentration divided by change in time, that is 20 seconds given. So change in concentration is 0.1 times 10 raised to the power minus 3 divided by change in time, that is 20 seconds. So we will get the answer equal to 5 into 10 raised to the power minus 6, and that is equal to option A. So option A is the right answer here. Then question number 15. The diagram shows the Boltzmann constant distribution curve, and the values shape is given. Points x and y are points on the vertical axis, but is represented by both points x and y. We have to tell what x and y represents. The point x is intersecting with this EA line, and we know EA is the activation energy, or it is a number of the molecule. It is the energy of the molecules which require for the reaction to occur. So X will indicate number of molecules with energy equal to EA. So that's the right answer. And the point Y. Point Y, you can see clearly here that it is at the highest point. It is present at the highest point over here. I can show you what's the purpose of this highest value over here. For this purpose, I have to show my notes. Okay, I have opened my AS lecture notes. You can get a file of these notes in PDF form. In this page, you can see that this is the Boltzmann curve, and this arrow represents the most probable energy with the molecules present by the highest amount. The molecules, the y-axis indicates fraction of the molecules with energy. So most of the molecules contains energy equal to this point. Most of the molecules. So it is the largest number of molecules with this energy, with the same energy at this point. And as we move to the right side, the number of molecules are decreasing and the energy is also increasing. So very less number of molecules are present on the right side which have energy equal to and greater than the activation energy. Now we are back. Uh, so point Y is basically the largest number of molecules with the same energy. Largest number of molecules with the same energy. We cannot select the amount of energy or the greatest number of molecules because the amount of energy or the greatest number of molecules can be present in the whole of this area. The amount of energy or the greatest number of molecules. We do not know the exact energy of those molecules. So, the type of the energy. Basically, at this point, the energy is same. The energy for the molecule is same at this point, and they are largest number. So we have two ticks over here. This indicates that option A is a right answer. Option A is a right answer. Now, next question number 16. What are the acid-base nature of and structure of SO2? We know that SO2, the sulfur atom belongs to group number 6, and the oxides of the non-metals, sulfur is a non-metal, so the oxides or non-metals are acidic in nature, so it is acidic, and it is a small molecule. It is not a giant, it is a small molecule, so we'll select supermolecular. So the option B is a right answer. Option B is the right answer here. Now next question number 17. Element X and Y are present in period 3 of the periodic table. Element X is either phosphorus or sulfur, element Y is either sodium or magnesium. So we have to identify the element on the basis of the properties given. It indicates that element X forms an oxide that reacts with water to give a solution containing aqueous solution anion as XO42 minus. So element X can be phosphorus or it can be a sulfur, and this type of the anion is given by the sulfur, that is SO4 2 minus. You can also use the oxidation number to confirm this. So it is SO4 2 minus, which means this can be sulfur. Now about the element Y, the element Y can be either sodium or it can be a magnesium. Now according to the properties, it says that 1 mole of chlorine molecules react with the Y, and at the end of the reaction all of the element Y and all of the chlorine molecules have used up. So we have to construct equations to confirm this. If let's suppose we take sodium as the element of Y, it must react with the chlorine to give us sodium chloride. But here you can see that two atoms of chlorine are not completely used while during the formation of NaCl. There is one atom over here, so it is not completely used. But if we use magnesium to react with the chlorine, it gives us MgCl2, since the oxidation number of Mg is plus 2. So both the atoms of chlorine are used here. So it is completely used. Chlorine is completely used during the reaction. So that's why it must be magnesium. So sulfur is a right option and magnesium is a right option from Y. So the correct option becomes option D. Question number 18. Q is a semiconductor. The chloride of Q reacts with water to form white fumes and an acidic solution. Which period 3 element is Q? So it is clearly seen that Q is called as semiconductor, and we know that metals are a good conductor, non-metals are non-conductors. Phosphorus is a non-metal, it is a non-metal. Magnesium is a metal, aluminium is a metal. So the only silicon is called as metalloid, which you studied in O levels as well. It is called metalloid. Metalloid means semi-metal or semi non-metal. Semi non-metal. So it is the element which is present here. So silicon is the right answer. Now question number 19. V and W are two compounds. Each one contains a different group 2 element. A sample of each solid given to water shaken in pH, the pH solution is measured. So we have to find which is V, which is W. Here we can see that V is such type of compound which gives such a high alkaline solution. So going down the group, the hydroxide solubility increases. Down the group, down group, its solubility increases. Down the group, solubility increases. Solubility increases, which means it must be hydroxide and sulfate, and sulfates do not give us the alkaline condition. So from C and D, it must be barium, since going down the group, magnesium is above and barium is at the bottom. So barium is a right from here, and it cannot be it cannot be sulfate. It must be hydroxide. So hydroxide is here. Now, according to W, W is such a compound which has somewhat alkaline solution but not very strong. So again, we know that going down the group, barium is present by is giving more alkaline solution as compared to magnesium, which is present at the top position. So magnesium is must be there. Magnesium will give the sulfate will not give us the alkaline solution. Instead, magnesium hydroxide will give us the alkaline solution. So hydroxide is there, but that of magnesium. So the only correct option is C here. Now question number 20. This question number 20 here. Compound L decomposes on heating. One of the product is gas M. The M reacts with hydrogen to form peroxide acetyl nitrate. And what could be the formula of L? Okay, this question is basically linked with the peroxide acetyl nitrate PAN. We do not know the formula of PAN, which is not given in this question paper. For this purpose, we have to look for the literature. But what we can see that L is decomposing to give product gas M, and that M reacts with the hydrocarbons, unburned hydrocarbons, that is CXHY. So which gas is reacting with this CX to make the pan, and we do not know what the pan's formula is. For this purpose, I have to go to my notes. Okay, this is the page from my notes. Again, I can tell you that you can get my notes in the PDF form by reaching me out on my WhatsApp number or in the comment section. So peroxide acetyl nitrate and its formula is given here. It is CH3CO3 NO2. CH3CO3 NO2 is the formula of the PAN, peroxide acetyl nitrate. Now, how is it formed? It is also given here. Hydrocarbons reaction with O2 with NO2 to make this compound CH3C triple O3 CO3 NO2, which means hydrocarbons is already given, but we need these two products as well, O2 and NO2. Now, going back to the question, which of these compounds will be decomposed in heating to give that NO2 and O2? So, calcium nitrate formula is wrong. It is not the right formula. Mg carbonate will not give us NO2. It will give carbon dioxide. So it is wrong, and it is also, by the way, it is wrong by formula as well. And D is giving the right formula, but D is giving the wrong formula. The formula is wrong. Wrong formula here and wrong formula here. However, Nitrate is the only compound of calcium which will decompose to give us NO2 plus O2. So this is a correct answer. That NO2 will then react with O2 with one hydrocarbons to give us the pen. Now question number 21. This question is repeated from the past year and it is also a part of the examiner report. You can also read the examiner report of this question from this year paper to get more detail. This question says that sulfuric acid is added to potassium chloride and the fumes produced are bubbled into the aqueous solution of iodide solution. So basically what is happening here that we will react H2SO4 with KCl and this will produce HCl. If this is produced, then the observation of this reaction 1 should be colorless since it is a colorless solution. It can easily dissolve, acid can easily dissolve in the water. So in aqueous solution it will be colorless. Now observation 2, which means for reaction 2, KCl is dissolved in aqueous ammonia and is then added to silver nitrate. Basically, if you look at the verse, they have reversed the process to identify the halidine. We usually react the reaction with the silver nitrate and then the product is added in the ammonia. It is initially done and then and the second, this is first step and this is second step. However, in this case they have reversed the step and they are saying KCl is added in the ammonia first and then added into the silver nitrate. It is a reverse process. So if you add KCl in the ammonia, it will also give you the colorless solution. It will be colorless solution. So colorless solution is the right answer. Precipitate cannot be formed here because it is not reacting with the Ag. So the right option becomes C option here.